at an angle minus 36.48. Okay. So in this way, what we get is we get I120. So I will write here I120 is 0. I121 you have just now got 0.2274 at an angle minus 36.47 degree, and I122 is 0.2269 at an angle minus 36.48 degree. So once you substitute this here, I12 ABC will be obtained, and in this way you can get the answers in the phase component. So ABC means phase component, and 012 means the sequence component. So in this way we have completed the numericals related to the LG fault. Now let us start with the numericals related to the symmetrical fault. We know there is two type of symmetrical fault that we have in a power system network. So what are the symmetrical faults? The symmetrical faults are either three-phase fault or three-phase to ground fault. So these are the two types of fault that we know in case of the symmetrical fault. So we have to first start with the fault current. So I will write the formula for fault current. So only the formula for fault current will be changed here. Rest all the formulas will be same. So I will write the fault current. So the formula for fault current IF is equal to Vk of 0 upon Zkk1 plus Zf. This will be the general formula in case of the fault current, because here we know that only positive sequence component is present in case of the symmetrical fault. So only positive sequence component is available in case of a symmetrical fault. So this we have to remember. In case of a symmetrical fault, we have only the positive sequence component available, and negative sequence and zero sequence are absent. Negative sequence and zero sequence components are absent. Okay, so this we need to understand, and with this we will start with the these 2 points. You have to remember that in case of a positive three-phase network, only the positive sequence component is available, and the zero sequence and the negative sequence components are not available. So in case of this, we have to remember only this fault current formula. We have to remember this fault current formula itself, and rest all the things we will make use of the previous parts that we have seen. Okay, so please write this fault current formula, and here it will be 1 because this is for positive sequence component. So write this formula. We will start with a numerical now. So let us start with a numerical. Let us write the numerical. So we are starting with the symmetrical fault. So we will start the formula. Sorry, the question. The question is the per unit impedance matrix for the power system the per unit impedance matrix for the power system shown in figure is as given below. So ZBus they have given, let us write ZBus. ZBus is equal to J is written in common, then 0.0150, 0.075, 0.140, 0.135, then 0.075, 0.1875, 0.090, 0.0975, then 0.140, 0.090, 0.2533, 0.210, then 0.135, 0.0975, 0.210, and 0.2475. So this is the ZBus which is given to us. Obviously, this ZBus is a positive sequence component ZBus because as the problem is related to the symmetrical fault, we know that in symmetrical fault, we require the positive sequence component only. So in the numerical itself, the provided system is given here. So this is the ZBus which is given to us, J in common. So all the be having J with it. Okay. So this is the ZBus which is given to us. Now let us write the or let us draw the power system network diagram. So this is the ZBus. Let us now draw the power system network diagram. So power system network diagram is drawn in this way. So there is a 4-bus system. That's why you can see that the matrix is also a 4 by 4 matrix. So as this is a 4-bus system, the matrix is also a 4 by 4 matrix. So 1, 2, 3, and 4. These are the 4 buses. Why do we require this diagram is to find the interconnections of the system. That is, with which bus the other buses are connected. For the interconnection, we require the network diagram. Okay. So in this way, the network diagram is given. The self-impedance values are also given in this way. So in this way, the system is given to us as well as we are provided with the ZBus. Now let us see what is asked in the question. What is to be found in the question. So they have given a three-phase fault occurs at bus number 4 through a fault impedance of ZF is equal to 0.0025 per unit. Using ZBus, calculate number 1 fault current, number 2 bus voltages, and number 3 line currents during the fault. So this is the question which is given to us. Please write the question first so that we can start with our solution. This is the question. The per unit impedance matrix for the power system is shown in figure is as given below. So they have given us the ZBus. Obviously the numbering of this ZBus would be in this way. Generally we write the bus numbers, but as not given here, we can assume the bus numbers in this way: 1, 2, 3, 4, 1, 2, 3, 4. So this was not given in the problem. We have identified this bus number as per our requirement. So is it complete? Shall we start with the solution? हो गया सबका क्वेश्चन लिखे? Shall we start with the solution? Okay, so let us start with the solution. So first we will start with the first part. First part, what they have asked is, they have asked the fault current. So we know the formula for the fault current. What is the formula for the fault current? I will write here the formula once again. IK1 is equal to VK0 upon ZKK1 plus ZF. That's it. So this will be the formula for the fault current. Now here in this case, K is equal to 4. Why? If you will read the question carefully, you will see that. Okay, so I will just write the things once again here so that you all will be able to note it down. So fault has occurred at bus number 4, right? So our formula will be in this way. I41 will be equal to V4 of 0 upon Z441 plus ZF. Okay. Now this is the pre-fault voltage VK0. So this we have to always take 1 at an angle 0. Z441 is Z44 value which is already given to us in the ZBus. So this is 2475. So I will write here 2475J plus ZF. What is the value of ZF? value of ZF is 0.0025. So from here you will get this result as 4.0401 at an angle minus 89.42 degree. Don't forget to write per unit, because even though this is a fault current, the unit will be per unit, because all the values which we have considered are in per unit. Next, we have to calculate the I for ABC, that is the phase component. So this is equal to 1, 1, 1, 1 alpha square alpha, 1 alpha alpha square. This is the transformation matrix. Then here we have to write I for 0, I for 1, and I for 2. So from here, what do we get? Let us see. From here, we will get 1, 1, 1, 1 alpha square alpha, 1 alpha alpha square. And now, when we substitute the value of I for 0, so here in this problem, you can see that 0 sequence component is not present. So we have to simply substitute this by 0. Then I for 1, we have just now calculated. So this is 4.0401 at an angle minus 89.42 degree, and the negative sequence is also 0. So in this way we substituted IK0, IK1 and IK2. Now we have to solve this. So when you will solve this, the first component you will get 1 multiplied by 0 plus 1 multiplied by 4.04 at an angle 4.0401 at an angle minus 89.42 plus 1 at 1 multiplied by 0. So the first term will be as it is, that is 4.0401 at an angle minus 89.42 degree. So this will be the first term. Then what about second term? So when we will calculate the complete things, we will get the second term as 4. Has anyone calculated it? Yes. So 4. We will get the result as 4.0401 at an angle 150 degree. And the last one we will get 4.0401 at an angle 30.58 degree. So in this way we get the results of correspond to phase A, will correspond to phase C. See here, as this is a three-phase fault, every time you will get the magnitude as same. So you can see here the magnitude is same, only the change is the angle. So you can see here the difference between A phase and B phase is 120 degree. Again, the difference between B phase and C phase is also 120 degree. So that's why whatever we have solved, it means that this is correct. Okay, is it clear, everyone? So in this way, what we have got is the first part. So this part is the first part, that is the fault current. So first part answer is obtained. Now let us start with the second part. What is the second part? Second part is the bus voltage. So for bus voltage, we have the set of formulas already available with us. It will be same. It will not change. Only the change is in the fault current. That's it. So we have to change the fault current formula. Rest of all the formulas will be same, which we have used in the line to ground fault. But here we have to consider only the positive sequence component, because the negative sequence and zero sequence component is not present. So in case of the bus voltage, we have the formula available with us for the bus voltage with reference to the positive sequence component in this way. Vi1 is equal to 1 minus Zik1 IK1. This is the formula that we have for the bus voltage with respect to the positive sequence. Zero sequence, negative sequence तो है ही नहीं, है ना? तो zero sequence और negative sequence हमने calculate करना भी नहीं. क्यों? क्योंकि ये थ्री फेज फॉल्ट है और थ्री फेज फॉल्ट में जीरो सीक्वेंस और निगेटिव सीक्वेंस ये दोनों ही सीक्वेंस रहते नहीं है, इसीलिए हम ये दोनों सीक्वेंस को कैलकुलेट भी नहीं करेंगे क्योंकि जीरो ही आएगा इसका आंसर। ठीक है, सो व्हाट वी विल स्टार्ट विद, we will start with bus number 1. So I am going to calculate here for bus number 1. Rest of the three buses you have to calculate. अब बस नंबर 4 पे फॉल्ट अकर हुआ है तो बस नंबर 4 का वोल्टेज निकालने का कोई काम नहीं है क्योंकि उसका आंसर जीरो आएगा। अगर हम कैलकुलेट भी करते हैं तो द आंसर विल बी जीरो। सो वी विल स्टार्ट विद बस नंबर 1. फॉर बस नंबर 1 I will be equal to 1. So we will see how this equation will be now. V11 will be equal to 1 minus Z1. K क्या है? K 4 है क्योंकि फॉल्ट कहाँ आकर हुआ है? 4 पे। So equation becomes in this way 1 minus Z141 and I41. तो इस तरीके से हमें ये इक्वेशन मिलेगा। अब Z14 के लिए हमें टेबल में जाना पड़ेगा जो ZBus का दिया हुआ था क्वेश्चन में। ZBus के टेबल में हम I14 चेक करेंगे तो I14 हमें मिलेगा 0.135 1 हमें मिला हुआ, क्या मिला हुआ था? I41 हमें एट एन एंगल 9.42 डिग्री। तो यहाँ से हमें क्या मिलेगा? V11. So calculate V11 and reply first. Once we get this V11, we have to calculate the V1 ABC. So V1 ABC will be equal to 1 1 1 1 alpha square alpha 1 alpha alpha square और यहाँ पर हमें लिखना पड़ेगा जीरो क्योंकि जीरो सीक्वेंस है ही नहीं। उसके बाद पॉजिटिव सीक्वेंस जो हमें अभी मिलेगा। तो कितना मिला है हमें? हमें मिला है 0.4546 एट एन एंगल -0.69 डिग्री पर यूनिट ऑब्वियसली। सो पॉजिटिव सीक्वेंस के टर्म में हम यही चीज लिखेंगे 0.4546 एट एन एंगल -0.69 डिग्री और निगेटिव सीक्वेंस के जगह पे हम लिखेंगे जीरो। इसको सॉल्व करेंगे तो हमें मिलेगा VIABC। तो VIABC का फर्स्ट टर्म ऑब्वियसली यही रहेगा 0.4546 एट एन एंगल -0.69। अब सेकेंड टर्म बताओ मुझे क्या आता है? सेकेंड टर्म का मैग्नीट्यूड ऑब्वियसली सेम रहेगा, ओनली एंगल आपको चेंज करना पड़ेगा और एंगल भी जो चेंज करोगे वो कितने से चेंज करोगे? वो एंगल आपका चेंज होगा 120 डिग्री से, बराबर। तो बताओ मुझे सेकेंड वाला आंसर कितना आ रहा है? इसके लिए क्या करना पड़ेगा आपको? 1 मल्टीप्लाइड बाई 0 इज 0। अल्फा स्क्वायर मतलब क्या? 0.4546 एट एन एंगल -0.69 मल्टीप्लाइड बाय 1 एट एन एंगल -120 डिग्री। सो 1 एट एन एंगल -120 डिग्री लोगे और 0.4546 एट एन एंगल -0.69 से मल्टीप्लाई करोगे तो हमें ये यहाँ पे सेकेंड आंसर मिलेगा। जल्दी से बताओ सेकेंड आंसर क्या आ रहा है? Similarly, third answer, magnitude will be same, only the changes will be in the angle part. So please reply fast. जल्दी जल्दी reply करो। Very good. So the answer is -120.69. So -120.69 is the correct answer. Similarly, next one क्या है वो बताओ? Next one will be 1 मल्टीप्लाइड बाई 0 0 आएगा, फिर अल्फा मल्टीप्लाइड बाई दिस, तो इसका मीनिंग क्या होगा? 0.4546 एट एन एंगल -0.69 मल्टीप्लाइड बाय 1 एट एन एंगल 120। तो यहाँ से हमें ये क्या मिलेगा? यहाँ से हमें ये मिलेगा 119.31 राउंड ऑफ करके मैं इसको ले लूँगा 3 1 एंड ऑब्वियसली ये सारे आंसर्स मुझे किस में मिले, ये सारे आंसर्स मुझे मिले पर यूनिट में. So in this way, what I have done is I have calculated the bus voltage for bus number 1. ठीक है. Similarly आपको क्या करना है, बस नंबर 2 और बस नंबर 3 के लिए निकालना है. तो सेम फॉर्मूला रहेगा. बस नंबर 2 के लिए क्या हो जाएगा, बस नंबर 2 के लिए आपका फॉर्मूला चेंज हो जाएगा. कैसे, V21 इज इक्वल टू 1 माइनस Z241 I41. सिंपली आपको क्या करना है, यहाँ आपका जो ZBus है, ZBus का वैल्यू आपको यहाँ पे 24 का लेना है. 24 क्या है आप ZBus से देख लेंगे. 24 है 0.0975J और मल्टीप्लाई करेंगे आप आपके I41 से. तो I41 क्या है, 4.0401 एट एन एंगल -89.42 डिग्री. यहाँ से आपको मिलेगा V21. फिर जैसे आपने V1 ABC निकाला वैसे ही V2 ABC निकालोगे बाय यूजिंग ट्रांसफॉर्मेशन मैट्रिक्स एंड गेट द रिजल्ट ऑफ V2 ABC. सिमिलरली V3 ABC ऑल्सो. ठीक है. तो इस तरीके से आपको क्या मिलेगा, V2 ABC. फिर आपको बस नंबर 2 के लिए भी निकालना है. बस नंबर 2 के लिए निकालोगे तो फॉर्मूला कैसे बदल जाएगा, 3 के लिए निकालोगे तो V31 इज इक्वल टू 1 माइनस Z341 I41. अब 34 की वैल्यू देखोगे ZBus से और सॉल्व करोगे. ठीक है. तो इस तरीके से हमारे ये प्रॉब्लम्स सॉल्व होते हैं रिगार्डिंग द 3 फेज फॉल्ट. ठीक है. इससे रिलेटेड एक और क्वेश्चन हम लेंगे कल के लेक्चर में और इस तरीके से हमारा ये यूनिट नंबर 5 कंप्लीट हो जाएगा.